Hello, I'm Janez, and today in this talk we will talk about state management without pain. So I'm from Ljubljana, Slovenia, and there's a picture of Ljubljana. This is the capital of Slovenia, and I work there as a JavaScript engineer at an agency called Povio Labs. At Povio Labs we mainly create web stuff like web apps, websites for US-based startups. My two passions, one is music, which is great because the theme of this conference is music, and the second one is teaching, so teaching web development online. Let's see the agenda for today's talk. This talk will be quite focused on using state management libraries with React, but the libraries itself are framework agnostic, so you can use them with any framework or with none at all. We will take a look at two biggest players, those are Redux and MobX, and we will explore some differences between those two. Then I will pick MobX as our primary state management library, and we will explore some core concepts, some advanced concepts of MobX, and I will provide you with some hopefully useful add-ons to MobX, what to use with MobX. But first, I want to get to know you. What state management libraries are you already using with your projects? This can be either your work projects or your side projects. By the raise of hands, how many of you are using Redux in your projects? Okay, there's quite a lot of hands. And how many of you chose an alternative called MobX? Oh. a few less. And how many of you are using something else, either with another framework or just something default? Okay, that's a lot of hands. Cool. So let's take a look at the current state of state management in React. We have an option of using React's set state, which is a default option, so you are keeping your state in your components. And once you need this state in multiple components, you just lift it up and pass via props. This is the most basic way of keeping your data in components. But then once you get to do this, it's called prop drilling, when you pass your props through multiple components to get to your final wanted component, you go on a hunt for state management libraries. And two biggest of those are, first is Redux, which promotes immutability and one-way flow, one-way direction of data. And the second one is MobX, which is more automatic, it's reactive, and it promotes something called derivations from your data. We will take a look at what that means later. And you also have other options, like using context API from React, or using something just announced called React hooks. So let's compare Redux and MobX as libraries. I took the screenshot of stars on GitHub last week, and as you can see, Redux is more popular in the community. It has a bigger number of stars. And by default, Redux uses more boilerplate. You have action creators, reducers, stores, and so on. But the core code is really simple. It's really easy to understand. On the other hand, MobX uses less boilerplate. You just wrap your state as an observable, and it becomes reactive automatically. And it is a little bit more magic. In Redux, you have a concept of a single store. You are keeping all your data in one store, and in MobX, it's usually multiple stores, like multiple domain stores, and a common store like UI store. In Redux, you are storing your data as plain JS structures, and in MobX, on the other hand, you wrap them in observables. In Redux, it's common that you have normalized data, and for MobX, this is not the case. You can have deeply nested data. So Redux manually tracks updates. It's quite explicit how you do actions, and it's passive. On the other hand, MobX automatically tracks changes, It's reactive and implicit. So let's choose MobX as our primary state management library, and here we will explore 3 core concepts of MobX. The first one is state, those are the observables. The second one is are derivations from data, and the third one are actions. So let's get to look first at state, the observables. So anything that is a value that changes over time can be defined in a store or component as state, observable. For example, on the left side, we have a React component which consists of 2 observables, a price and amount. And we are just decorating those with decorators at observable. As you can see, we are using decorators, and the code becomes more readable, more declarative, and we can use either Babel or TypeScript compiler to convert those decorators. The next core concept of MobX are derivations from your data, and we have 2 types of those derivations. The first one are computed values, and the second one are reactions. On the top right, we have an example of computed value, which is a total number, which just multiplies the price and amount from state data. So computed values are values that are made of multiple state values. And the nice thing about those is that they get cached and only recompute when the dependency changes, either of the dependency changes. So if the price changes or amount. And when a computed value is not used anymore, it gets automatically garbage collected by MobX. The second type of derivations from your data are reactions. So we are observing the data from the store, and we are running some side effect. For example, on the right bottom, we are observing the total from the store, total value, and we are producing a side effect of consoling out this total when it changes. There are 3 types of reactions in MobX. Those are auto-run, which is the simplest one, when is another one which runs only once, and reaction from this example gives you a more fine control of what you are observing and what the side effect will be. We have another reaction in MobX which is called observer. This is what we use to wrap the React components to get the changes from the store. And the third and the final core concept of MobX are actions. Actions are something that modifies the state. This is really similar to Redux actions, but there's a difference because here we are directly manipulating, mutating the data from the store. For example, on the left side, in the increment action, we are calling this price ++. And under the hood, actions in MobX implement something called transactions, which means that even if we change in this increment action the price state multiple times, only the last change will be presented out, which is great for performance. There are some utilities we can use in MobX that helps us. The first one is that because state in MobX is represented as observables, we need a way to convert it to normal JS structures if we need it. And this is what 2JS is used for. And in the background, it creates a deep clone of an object or primitive. Because MobX is a reactive library, it quite nicely connects with other reactive libraries like RxJS. For example, we have 2 helpers here which are converting from RxJS stream to observable and vice versa. We have some other utilities. For example, trace is one of them, which helps us with debugging to know what MobX is doing in the background. And the second one are MobX dev tools, which are similar to Redux dev tools, So they show you what gets re-rendered from your changes in the stores, or they show you the dependency of data in your store. Let's explore some best practices with using MobX and React. The first and probably the most important one is that use small components and subscribe to only the data you need. This is what we can use the observer reaction for. So we are creating a small components, we're adding the observer decorator, and we are subscribing only to the part of the data from the store. Use computed values for simple derivations, like from earlier example, we had a total which doesn't need another state variable, but can be derived, and it's cached. And for code readability, use decorators for the nicer code. But if you need more strict store organization with types, you can explore MobX state tree. This is what we are going to see now. So MobX state tree, it's a state container, a tree, and on the right side we have an example of MobX state tree counter store. Under model, we are defining the same as earlier, the price and amount, observables, which are the type of number. And we have actions, like increment action, and views. Views are computed values. What are some advantages of using MobX state tree? The first, which is really nice, is that it solved this problem. If you can see at actions and views, we get self-passed on. So for example, if we are incrementing a state variable, we just call self.price++. Another thing really useful are lifecycle hooks. So similar, if you are working with React, you probably know lifecycle hooks from components. This is the similar idea, but in MobX state tree store. Here, I'm just declaring an after grade lifecycle hook, and I'm setting the interval to increment it every second. We have multiple of hooks. One is after create, before destroy, and so on. And MobX state tree under the hood, it uses TypeScript, so it provides you with runtime type checking. For example, you get some bad data from API, it will fail in runtime. What are some caveats of using MobX state tree, of adding MobX state tree to MobX? First, it adds some overhead because it has to do all of this type checking with TypeScript every time. We tested it in our production app with large arrays of data, like thousands of objects in an array, and the replacing, the updating of this data gets slower. It's nice if you need like strict store organization, but if your app is like depending on really performant app, you should use maybe an alternative, which will be just MobX plus TypeScript, which means faster state setting and compile time type checking. And that's it. If you want to get more info about either MobX or MobX state tree, you can visit those two links. This is the documentation of those libraries. Thank you.